Welcome to all. Today we are going to see about multiplexers and filters. Optical filters are the important components of a optical network or an optical transmission system. The optical filters is very important. It does two things. One is it is used to multiplex. That is, the devices which is used to combine more than one signal is called as a multiplexer. And demultiplexer, if you take, means it is used to separate the wavelength in a wavelength division multiplex system. So this is one of the application of a filter. Another one thing is it provides equalization of the gain and filtering of noise in optical amplifiers. The gain should be uniform throughout the passband and unwanted components have to be eliminated. This is done by using optical filters. So this is a diagram of a diagram for application of optical filters. See, this is the input port, this is the output port, this is the port. It is a third additional port. So, these lambda 1, lambda 2, lambda 3, lambda 4 are the wavelength or signals that is traveling along a single length of a single fiber, or it is fed as input. So, this filter, it is just passing or selecting one of the wavelength, for example lambda 1, and it is letting out. The remaining lambda values, the remaining signals are rejected, so are blocked, we can say. It is available in the third port. Next, this wavelength multiplexer. It is a device. It is used to combine more than one signal. So in here 4 signals are available. It is combined, and now in the output it appears as a combination of the 4 signals. So what is a filter? It is a 2-port device. It selects one of the wavelength and rejects other. So an additional third port is available, which is used to send the rejected wavelength outside. So what is the definition of multiplexer? Means it is used to a device which is used to combine the signals at different wavelengths on its input ports into a common output port, and demultiplexer performs just the reverse function of a multiplexers. Multiplexers and demultiplexers are used in wavelength division multiplex terminals as well as in larger wavelength cross connects and wavelength add drop multiplexers. Next, key characteristics of optical filters. These optical filters should have low insertion loss, that is the loss between the input and the output, that is called insertion loss. This loss should be less in optical filter. And another one thing is this loss should be independent of the state of polarization of the input signal. It should be independent of the orientation of the field components of the input signal. Next, filter, if you take means it will have 2 bands, pass band and stop band. The pass band of a filter should be insensitive to variations in the ambient temperature. That is, the range of frequencies supported by the filters or passed by the filter shouldn't change depending upon the ambient temperature or the surrounding temperature conditions. Next is, if you want to, if suppose you take a number of filters are available, they are cascaded. If you want to have a broad pass band at the end of this cascaded filters, means the individual filter is supposed to have flat pass band so that even a small changes in the operating wavelength of a laser can be accommodated. This is measured by dB bandwidth, 1 dB bandwidth. So each and every filter is supposed to have a flat pass band. Next one is, see this diagram. This is the pass band. This is a 3 dB bandwidth. This is a 1 dB bandwidth. So this is flat. This should be flat enough. So this is the range over which the filter allows the frequencies to pass through. It should be flat enough. So this is called skirt, pass band skirt. This should be sharp enough so that the signal from the neighboring channels can be avoided. So if it is not sharp, means here the crosstalk energy can be moved. If it is sharp, means this can be reduced. So the pass band skirt should be sharp in order to reduce the amount of energy passed from the adjacent channels. So we have to select a filter in such a manner that the pass band skirt is very sharp. This, the energy from the adjacent channel penetrating into the desired channel is seen as crosstalk. So this crosstalk affects the performance of the system. So it has to be minimized, suppressed. So the crosstalk suppression or isolation of the filter, how it is defined means it is defined as a relative power which is passed from the adjacent channels. So this is very important. Crosstalk should be avoided. So how we have to suppress the crosstalk means first we should know what is the definition. It is a relative power passed from the adjacent channels. Another one thing is whatever the filter we choose, its cost should be less. Next subtopic is optical amplifiers. But prior to optical amplifiers, regenerators were used. Why this regenerator was used? The optical signals was attenuated with optical filters as they propagate to the fiber. How means loss is occurring. It is reflected. It can be absorbed. So there is a loss of signal strength. Another one thing is some components like multiplexers and couplers, demultiplexers are added. This also increases the loss. After some distance, the loss of the signal strength is very heavy so that we are not able to reconstruct it. The signal is very weak enough so it can't be detected. We are supposed to restore the signal strength in order to be detected. So in the earlier days, optical amplifiers was not available. So they were forced to use regenerator. So this regenerator is a device. It receives the signals and retransmits it. So after receiving the signal, what it is doing is it is converting the optical signal to an electrical signal. It is cleaning it. That is, the signal is cleaned here. The noise is removed and it is converted back to an optical signal for the further propagation of the signal. So what is a regenerator? It is a device that converts optical signal to an electrical signal, cleans it up. Regenerator can be defined as a device that converts the optical signal to electrical signal and the noise is cleaned up here. It is converted back to an optical signal for the further propagation for transmission. Next, why regenerators are avoided? This is because a particular regenerator can be used for a particular bit rate and a particular modulation format. That is, it is specific to a bit rate and modulation format. So, the system, for a particular system, a particular regenerator is. For another one system, we are forced to use another one regenerator. So, this is some of the disadvantages of regenerator. These disadvantages forced us to move to the optical amplifiers. Optical amplifiers is insensitive to the bitrate or signal formats. So whatever might be the bitrate or signal formats, the optical amplifiers can be used. It is independent of the bitrate or signal formats. The upgradation of this optical amplifiers is easy. Whatever the system that is using optical amplifiers can be upgraded easily. Then these amplifiers have large gain bandwidth. So single amplifiers can simultaneously amplify a number of signals. So your numerous signals can be amplified by using the optical amplifiers since it is having a larger gain bandwidth. But in the case of regenerator, if you take means for a particular wavelength, a single regenerator is used. The amplifiers are not perfect devices. Why? They itself has a capability to introduce noise. This noise accumulates. As the signal passes through multiple amplifiers, the noise level increases. As the signal that is propagating is analog in nature, this noise affects the signal. So, this is a diagram of wavelength cross-connect. So, it is having a single input. Number of signals are traveling lambda 1, lambda 2, lambda 3, lambda 4. So, from here, it is fed to this device, multiplexer. So, in wavelength cross-connect, it can be classified as static wavelength cross-connect and dynamic wavelength cross-connect. The static wavelength cross-connect routes a signal from an input port to an output port. This is the input port, this is the output port. It routes a signal from input port to an output port based on the wavelength. So, but it has some drawbacks. It is limited in terms of the functionality. Next one is dynamic cross-connect. It can be constructed by combining optical switches with multiplexers and demultiplexers. So this is one demultiplexer, this is another demultiplexer. These two are multiplexers. So this demultiplexer separates the signals. Then here, in a cross manner, it is connected to a multiplexer. So this signal lambda 1 as well as lambda 4. From here lambda 2 and lambda 3 is fed to those multiplexers. So this is a cross connect. Thank you.